Welcome to Quadrivium Mathematics. I'm starting a series. I want to put together a full high school curriculum that takes quadrivial mathematics as the foundation and yet still prepares students for calculus. I'm in the midst of a big project working on this for the Chesterton Schools Network, but I want to put the whole thing together for homeschoolers as well. So as a first step to that, I'm going to begin recording a lecture series that is meant as the backbone of a student's self-study and begin putting together my notes and my exercises as well. Eventually, this will sit on a website dedicated to the subject and hopefully become my career. But for now, I'm posting the videos for free on YouTube, uh, and the angle is going to be just to share it. Little of my background on myself. My name is Eric Mack. I've been teaching mathematics for going on 20 years. And as early as when I was in college, I really wanted to see why math and music were connected. And I found what little resources were available at the time when education resources on the internet were scant, and dug into how tuning actually worked. I had the beautiful opportunity from my parents, thank you, uh, to work on building a musical instrument as a senior project in high school. And the fascination with how the spacing on the fretboard worked stuck with me and really steered my career. So the angle of this for the quadrivium, for those who don't know what it is a four pathway methodology for approaching mathematical study that comes from antiquity. The four paths of the quadrivium are arithmetic, which in modern terminology we'd actually consider music, or not music, we'd actually consider number theory. It's what is measurement in general, and what does it mean to consider size versus multitude. Uh, they have this historical viewpoint where they broke apart um, the way that we count things with integers versus the way that we measure things with geometry, and they thought they were very discrete from one another. So they didn't have a conception of cutting the integer number line in pieces. It would make sense to have 5.5 cows. You can't trade those. So when they were dealing with the metrics of how you count things in the world, there's a natural discreteness to it. You can't put something halfway between male and female. There's one or the other. Uh, so in that perspective, they understood that there was something inherently different about the counting numbers than from the measuring numbers, where it would make sense to talk about half a cow once the cow is being cut up and sold, and you can order half of a cow to get delivered to your freezer and parcels. So that's arithmetic. And then it goes beyond that into looking for patterns in arithmetic. So you've got evens versus odds, and you've got the pattern that you get when you start adding together the odd numbers and discover that those lead to the squares. And you have the pattern that you get when you start doubling things or having things over and over again that lead to exponents. Uh, and yeah, that's arithmetic. So the most famous extant book of arithmetic is attributed to Nicomachus, who was a Palestinian of the first century and most likely studied in Alexandria as well, so that neck of the woods. The second subject of the quadrivium is music. And this was where my heart was at and why I was so thrilled to pursue this angle. Uh, while I was teaching as a college professor for 8 years, I had the beautiful privilege of creating and offering annually a course on the mathematics and aesthetics of musical tuning, where we dove into how did the Greeks come up with a tuning system? How was that modified in the Middle Ages? What philosophies kind of went along with this? So we talked about um, the harmony of the spheres and how that led to a whole um, philosophy of life that was grounded on music in some sense. There's a famous one-liner loosely attributed to Pythagoras that music soothes the savage beast. There's a historical, probably apocryphal story, but maybe not. Uh, Nicomachus walking, or not Nicomachus, Pythagoras walking into a situation where a gang of young overactive men were about to take advantage of a woman, and he didn't like seeing this at all. And so he grabbed the harper that happened to be around playing something. He retuned their instrument and playing something different, uh, took them down off of the trajectory that they were on, and saved them. Saved the woman too, thankfully. So there's this perspective in Greek music that the way we deal with things musically will have external influence, and that we need to be very cautious about what we fill our ears and our heads with, lest it well, send us down the wrong road. Uh, Loosely, you could say that the concern in the 1950s about what rock and roll would do to the youth was, somehow connected to this idea. Um, There's a medieval example um, of people philosophically opposed to the new temperament systems, which meant that things were no longer in tune. They were making things intentionally out of tune to smooth out the spacing of notes. And they were starting to implement this on some church organs. And like, this is not good. We can't let this happen. I mean, what's this going to do to the faith if people are listening to out of tune music while they're trying to learn the truth? I mean, this is a big deal. So there were people sneaking into churches at night to sabotage these organs because they were genuinely concerned about what kind of, not different music, but this kind of different tuning would do to people. So it may seem far-fetched by today's standards. We certainly let far too much stuff into our ears than I think we probably should. We let a lot of sound influence into our lives that we might arguably be better for to have removed. I'm talking about like the hum of our lights in our public school system, and the whole general spirit of what does it mean when you go out on a backpacking trip out into the woods and you get away from everything and you can't hear the hum of the road noise of the freeways anymore. And what peace does that bring to your mind? So the Greeks were very much into that sort of thing. And I think we very much need to have more uh, direct study of those kinds of influences on ours. A lot of modern neuroscience really is pointing to the fact that there are some strange things that the wrong proliferations of sound can do to the way that we think, down to the you know, not necessarily musical, but sonic impacts of having two close but different frequencies played in each ear, and how for certain people that can lead to an epileptic seizure. So lots of crazy stuff that happens there that modern science is in some ways validating some of these early theories of the Greeks about what does it mean to have the sounds that we play in tune. So the quadrivial subject of music is not about what the music is about. It's not about what the lyrics are. It is about the way that musical notes interact with one another. And in fact, it's really about the way anything interacts with one another. So it's the study of relationships, a lot of it pairwise, where we relate two different things and say, what does this mean? Where we get the notion of fractions from, even though it predates fractions. Uh, and it's where we get the notion of ratio from, really, in some foundational sense. And from ratio, we get the sense rational. Um, so if you've never paused to think about the fact that the word rational, meaning thinking reasonably, and the word ratio, meaning just the relationship between two numbers, have some common root, it's worth thinking about that. It's tied up in the harmony of the spheres. There's something to be said there. Uh, and when irrational numbers were discovered, on one level, they were saying that, hey, they're just not expressed with ratios. On another level, they were saying, hey, they don't make sense. Same thing can be said historically for the development of imaginary numbers. They don't make sense. We coined them as imaginary because they were kind of out there a little bit. Now, As we got a deeper sense of what they are, we found out that they were very much in there. And imaginary numbers, or complex numbers as they were also labeled, turn out to be a cornerstone of understanding a great many things, and are actually quite beautiful mathematical objects that can be understood, but they need to be understood geometrically, not through this lens of arithmetic or even the lens of music. So that brings us to geometry. Geometry was the study of measure of size. So here's where it is appropriate to say, well, what is half of this or three-quarters of this? Or what are the different kinds of collections of lengths that you can even build out of a certain set of tools and rules? Uh, and the tools and rules of geometry are um, a straight edge and a compass, and logical deduction. And of course, everybody knows this. The most famous book of geometry is Euclid's Elements. Uh, it's actually the second most widely published book in the world until the invention of the printing press, and then I think even after that for quite a long time. Um, so it followed the Bible, but it was the math book of uh, medieval Europe and even early classical Europe. Uh, And he lays out a systematic approach to showing us the relationships between angles and side lengths and shapes in geometry, using just that logic and a straight edge, which was a ruler with no marks on it, and a compass, which was a tool used for drawing a circle that was viewed as being collapsible. It didn't hold its shape. So that meant if you wanted to copy a distance somewhere, you needed a method by which you could uh, construct that copied distance somewhere. It had to be all very rigorous and constructed. So let's back up to music for a minute. Uh, Music is quoted as being the only morally grounded discipline of the quadrivium. The rest of them are very scientific in nature. But music, because of its connection to our behavior and our hearts, because we use these rules to actually construct beautiful music, uh, it acts as a bridge to the humanities. And the quadrivium is beautiful because it does bridge to the humanities through music primarily, but through all of the quadrivium, we see patterns that we find in mathematics and that are then copied into art, or that we find in art and then are then recognized as mathematical. Classic, is it life imitating art, imitating life, comes up in here. But there are beautiful opportunities to pause and consider the meanings of our musical and mathematical words, and what do they mean in literature, and how have they changed over time, and how does that color perception of things, down even to just words that have numerical roots in them, like alternative, for example. Alternate. Sesquialter is a Latinate word that means the three versus two ratio, meaning that it's one more than two. So alternative is a two-ish word, if you will. Uh, there's obvious ones and there's less obvious ones. Triumvirate or triumphant. You might not realize that. If you stop and think about it, like, yeah, there's a three-ish kind of prefix in there, but where's that come from? Um, but there's a background behind that. There's a reason why those are three-ish words, so we can explore those. There's also the biblical numerical significances of 7 days in the week, seven sacraments, uh, the Hebrew word for um, a promise or a pact or a covenant of sort is a word that is closely related to the word seven. So there's lots of beautiful places where those things creep in too, and there's uh, some serendipities that we will run into where those precise uh, faith-based sort of numerologies find themselves popping up within music, governed purely by physics, uh, and yet we see those analogies and we see that the ancients saw those analogies and they painted them into the structure of our week and the names of the days in our week and the harmony of the spheres. And whether we know it or not, they're coloring our lives and our daily routines. And life is more beautiful when you know that they're there than when they're just creeping around in the background and you're none the wiser. So totally worth bringing that stuff in there. So the last quadrivial subject uh, is astronomy. And the first argument about medieval astronomy is, well, it was geocentric and they've got all the facts wrong and they didn't have the science to actually study things and they hadn't invented the telescope yet. And so there's a lot you can say, hey, it's just, it's not a finished science. Why should we bother to study it? So we'll put the spirit of the quadrivium in place for what we mean with that. So another breakdown of the quadrivium aside from the order I just went through, is to say, um, so the one order that we've went through is arithmetic comes first. Arithmetic bifurcates into the study of size, geometry, and the study of relationships in quantities, music. And then there is a reunion of those two, music and geometry, into astronomy, where it's the study of size and relationship together. Another angle on music is it's the study of things in time, whereas geometry is the study of things that are stationary. So we put stationary things and temporal things together, and we get the study of temporal thing or stationary measurable things in motion, and that's very much the spirit of studying the planetary motions. But in some sense, you can say astronomy is it's wider than just the planets above us. It's physics, really. It's anything where we want to consider things in place and in motion. So that's one model where we say kind of got a diamond shape with um, arithmetic and then two subjects and then kind of a reunion of those subjects in astronomy. Another angle that people have used to explain the quadrivium is that arithmetic and music are a silo that are looking at uh, the relationship of discrete and that geometry and astronomy are a silo that look at the relationship of the continuous. So discrete, again, are separated things, things where it's like you could speculate at the idea of something in between, but it doesn't really make sense. And continuous is the idea of things do occur on a spectrum, and there should always be something in between and two objects that you've already measured. So we've got the kind of bifurcated siloed approach versus the uh, things in space, things in time, things in space and time. But it's a beautiful connection of those things. So the modern interpretation, in at least my humble opinion, of what the Greeks meant by the study of astronomy, for me, really goes with that idea of time and motion. And that is calculus. Calculus is let's take the discrete static world of things that we can measure and the strengths that we can look at if we want to think physics sort of things. And then we say, but what happens when it starts moving? We can build a building, but then it's a different thing to say, well, how's that building going to behave when there's an earthquake or wind shifts? People start moving around in it. So the center of mass is always all over the place. Uh, is it going to behave the same way when we start putting that into a dynamic setting where we have to have motion playing out? So that's the quadrivium. It's beautiful. And what I'm doing is I'm taking the spirit of that quadrivium, what I've all just explained right here, and I'm mapping it onto a contemporary curriculum where we still have to acknowledge that it's important that we learn the skills of algebra. Algebra hadn't been invented when the quadrivium was in place. So where does algebra fit in there? It's again, my humble opinion, of the utmost importance that we get to at least some sense of what calculus is in a high school curriculum. Without doing that, it's like constructing a body without a head. Modern mathematics is built on the premise that we're going to get around to calculus eventually. The whole massive algebra train of pre-algebra, algebra 1, algebra 2, pre-calculus is all angling towards understanding calculus. The reality is, as the quadrivium shows us, is that mathematics is just that. It's a plural. It's a very multi-headed discipline. And there are lots of areas of mathematics you can study that we just don't even touch in high school. And lots of areas that you get maybe one introductory class for, even if you're a math major in college. So it's a web of interconnected study of patterns. That's what modern mathematics is. Quadrivium simplifies it to say, hey, there's four, but it's still a web. And it's in seeing those connections between the webs or seeing the different facets of the gem that we want to get our head wrapped around that we get to what the heart of mathematics is. And it's important that we get the beginning student some sense of that's what mathematics is. As far as abbreviations goes, it sounds a little bit silly, but the English have it right. They say they study maths. They put an S, M-A-T-H-S. And when we say the full word mathematics, there's an S. It is a constellation of interrelated degrees, and we need to see it in that light. So the modern view of just tracking through algebra, angling towards calculus, does the student a disservice by not giving them a perspective on what is the end that they're aiming for. We put the means before them and we say, this is all you've got to do, and trust me, it's important later. And the student asks, but what's this for? And why should I care? Because they're just doing symbol manipulations on a page and they don't have context. So we need to give them context. And we need to get them to calculus. We can't dawdle around with 4 years of algebra and have a student graduate with Algebra 2 and go, yeah, no, I really don't like mathematics and I'm not going to take it in college. So they actually never see calculus. So whether they make it all the way to calculus or not, the ideas of calculus are so important to culture, so important to contemporary science, so important to philosophy that every student, whether they feel to be a STEM student or not, needs to understand the ideas of calculus. And again, the quadrivium does a beautiful idea of that because many of the ideas of calculus were founded in ancient Greece. We just needed the algebra as the missing middle piece to really flesh it out all the way. But Archimedes famously, like in 1995, not that long ago, we discovered with X-ray technology a manuscript that had been bleached and overwritten that had uh, an explanation of how to find the volume of a complicated 3D region that we use calculus to do. And he essentially was following a calculus approach. Or the early methodologies for trying to calculate pi. We'll look at one of those. It's calculus. Nicomachus's, I won't even say Nicomachus, it goes before Nicomachus. Then Nicomachus discusses it. He discusses uh, the descending ratios of cutting things in half over and over and over again. So you start with one, you cut it in half, you get one half, you cut it in half, you get one quarter, you cut it in half, you get one eighth. This is known as Zeno's paradox. If we think of it in terms of distances, I can say, hey, the distance from me to the door is length one. If I want to go to that door, I have to cover half the distance. And I have to cover half the remaining distance. And I have to cover half the remaining distance of that. How do I ever get to the door? Because we've just described a process where it's going to take an infinite number of steps to just get close to the door. Really, really, really close to the door, but close to the door. Wow. And if it takes an infinite number of steps to get to the door, how do we get through the door? So there's the paradox hiding in there. And that's calculus. That's the notion of an asymptotic approach. That's the notion of convergence. That's the notion of an infinite series where we can say, hey, guess what? One half plus one quarter plus one eighth plus 1/16 plus 1/32 ad infinitum, even though you don't have time to add it together and do the arithmetic or figure out the common denominators or whatever that is, it adds up to one. And we can draw a picture to see that. And maybe that's my last point is the modern notion of mathematics is tied to abstracting everything down to a verbal argument. You have to find a way to put it in writing to prove that it is not just something that seems apparent in your picture or seems apparent in your conception of things. But Euclid's approach with the rules and tools of geometry, with the straight edge and the compass, marries in a certain diagrammatic component to the notion of what is proof. And while some people might argue that that means ancient mathematics runs a little faster and looser than our modern standards of rigor, uh, it's certainly more human, and it's certainly more approachable for a student. And I think it's really important. And so that's where I'm coming from. And I hope you will decide to come along with me on this journey and go through the lectures that I'm going to give and give this gift to your son or daughter by giving them something that is not dry and not boring, but still challenging and still angling towards calculus and fulfilling their high school requirements. And I aim, because I spent 14 years as a college professor, to give them the rigor that they need to be able to take a maybe more in-depth calculus class when they get to college as their first semester class. Because there's no reason that they need to redo any of this because we didn't do a good enough job. So I'm offering and promising that level of rigor if my program is taken seriously. Caveat that there's always room for somebody who wants to take this at a different angle, to choose to do less of the assignments, to just pay attention to the videos and watch them just for the entertainment value of getting this kind of exposure to mathematics. But if you do the homework that I assign and you take it seriously and you take the philosophies and uh, the motivations behind the way I want students to do the homework, you will build your brain to be a quantitative thinker in a very meaningful way. Thanks for listening to my introduction.